Yeah, thanks a lot, Mark, for the nice introduction. And yeah, hello and welcome everyone, also from my side. Yeah, as Mark said, I'm leading the field application engineering team at Pure Systems. I'm with Pure Systems for 9 years now in total. And in the next 25 minutes today, I will talk to you about the advantages of advanced variant management with Pure Variants for the IBM ELM platform. We'll talk about the challenges that we address with Pure Variants and also give you a high-level explanation on how it works conceptually, how this approach works that we follow. As promised in the description, I will also give you a brief look at the Pure Variants web client in combination with the Pure Variants connector for DOORS Next to give you an impression of the look and feel of the combined use of the IBM ELM platform and Pure Variants. But first, let me also say some words about Pure Systems. So Pure Systems is a privately held company. We are headquartered in Magdeburg, Germany, which is quite close to Berlin. We are operating worldwide with customers from different industries. Our mission is to enable our customers to increase their engineering efficiency so that they can reduce their time to market for new product variants, reduce their maintenance effort in engineering, and increase product quality by reducing manual steps in engineering of multiple variants. How do we achieve this? We achieve this by providing know-how and tooling to maximize the reuse of engineering assets like requirements, architecture models, test cases, and code, following the standardized, systematic, and holistic reuse approach called product line engineering. Our customers belong to different industries, mentioned it earlier, like automotive, rails, aerospace and defense, industrial equipment, medical devices. We have some customers in the energy sector, so quite diverse. But they all have the common challenge to keep their engineering efficiency high while having to deal with the growing complexity in their products and or in their overall product line, just by the amount of different variants they have to provide. So what are drivers for this? There are different drivers like the continuing digitalization of products, which increases complexity, the need to develop and maintain more and more product variants to cover different customer segments and also regions with different regulations. So this all has an impact on the amount of variants of your product that you have to initially develop, but also to maintain over time. As well as the concept of product updates with feature introduction after delivery. This is something we see more and more, for example, in the automotive industry, that cars are sold with the idea of selling afterwards additional features and including them, providing them in the product. Something you also see now with modern smartphones and also in other product categories. This requires you to have a very good management, not only of your versions of your products, but also of the different variants, because you don't want to, and you really can't, if you have a lot of product variants, you don't want to and you can't in parallel maintain all of them. I mean, imagine the amount of people, the complexity that you have if you really see each product variant with its own life cycle, managed by its own team, or providing different or separate updates to those different variants. You want to centralize as much of those updates as possible. And for that, you need a dedicated variant management strategy, a dedicated variability management strategy. So not only to manage the variants you have created, but also manage the variability in engineering assets while creating these variants and make use of automation wherever possible to finally profit by getting a competitive advantage, of course. So how are we related to this topic? What is our offering? We address these challenges by providing the best-in-breed product line engineering tool, Pure Variants, that comes with more than 20 connectors to leading engineering tools of different categories, including the full IBM ELM suite, to enable holistic variant generation and management across the whole system and software engineering lifecycle. Because this is where you actually introduce variability, not in production or logistics. Of course, you also have to deal with variability there. And not in the product configurator you provide to your customer. Of course, it's visible there, but it starts or it comes into existence in engineering. And this is where your domain experts are that have the knowledge you want to turn into great products in an efficient way. Complementary to our tool, Pure Variants, we offer our 20 plus years of experience in helping customers to make the transition from their current way of working to product line engineering with Pure Variants under the brand of Pure Consult. But that's not all. Thanks to our valued consulting partners, we can provide worldwide training and consulting services for product line engineering with Pure Variants. So in North America, for example, we have partnered with 321 Gang to ensure excellent support for our US and Canadian customers. In Europe and Asia, we also established strong partnerships to ensure excellent remote and on-site training and consulting in our customers' mother language. Let me talk a little bit about existing customers. And so basically to make the point here, you are not betting on an experiment here. We are a mature solution, or we have a mature solution to offer here. With Pure Variants, you rely on a major product that is used by top players from different industries. The global number 1 and 2 car manufacturers by production volume, all German premium car manufacturers, and the global top 3 tier 1 suppliers in automotive, for example, are making use of Pure Variants to manage variability in engineering assets. So if you are driving a car, the chances are quite high that you have a braking system, an airbag system, some advanced driving assistance systems, or your battery control, or even the whole vehicle that has been engineered with a tool chain that relies on Pure Variants for the systematic and holistic reuse of engineering assets. If you rely on public transport, you also might make use of products that have been engineered according to the product line engineering approach. So here, for example, Pure Variants is used by our rail and transportation customers to manage variability in trains, wagons, and landslide systems. Pure Variants is also used to control variability in rail signaling systems that are used across different European countries, of course, in different product variants. In aerospace and defense, 5 of the top 10 companies worldwide make use of Pure Variants to manage variability in engineering. So example products here are airport and air traffic management systems, commercial and military aircrafts, satellites, marine vessels and systems, radar and sensor systems, just to give some insight on what types of assets are or what type of products make use of that approach. And to be honest, on that side, defense, and we don't know in detail all the products where it also is used. Pure Variants is also heavily used in the industrial equipment, automation, and technologies industry. So, for example, chips are variant controlled there. Yeah. More and more industries are following and invest in product line engineering as a sustainable engineering approach and rely on Pure Variants as a trusted solution, like consumer electronics and goods, healthcare, and medical devices, or, for example, the energy sector. And we see more and more companies target or taking this topic as a strategic topic to increase engineering efficiency and manage complexity in engineering. Different factors like a growing ratio of software, cross-system aspects like security and safety of systems, different market regulations and laws, as well as different customer needs drive the number of product variants. It seems natural to reuse as much of the available engineering assets across those variants as possible. But a lot of times these assets are spread across different tools developed in separate teams, and the dependencies between those assets are not formally tracked to higher level features, customer visible features. This not only makes it hard to reuse assets of existing product variants in a new one, but also to maintain multiple variants in parallel. A lot of engineering capacity is, as a result, needed to separately maintain each variant, and the effort and the risk to introduce new errors increase with each new variant. So in a lot of cases, the building blocks are there, but the knowledge how to combine them is not easily available, but scattered across the minds of different experts, or only available for a single asset type. A typical warning sign that a company is giving away engineering efficiency are Excel sheets that the stakeholders create and share to somehow track variability in engineering due to a lack of a dedicated solution to deal with variability in engineering. Just relying on version control mechanisms is also not a solution. Version control enables engineering to collaborate and to track changes over time. It often supports creation of separate branches for managing the assets of different variants of a product, but it does not support engineers in understanding how the engineering assets inside of these branches should be different. If a change is made in one asset, or two assets from different branches shall be combined in a new product variant, what are the implications? Is the resulting product valid? In the end, you do not want to engineer your engineering to spend all their time answering those questions. If you capture this dependency knowledge in a formal way, you can automate the generation and updates of these engineering assets across product variants based on a repository of reusable engineering assets. This has a strong impact on your company's engineering efficiency that you can turn into a competitive advantage. This is where this approach is helping you with. Coming back to the solution we offer, how do we realize this? And now let me get more concrete. Pure Variants follows the feature-based product line engineering approach according to the ISO 26580. In Pure Variants, you create a so-called feature model that captures all the high-level features that you can include in a variant of your product along with their dependencies. You then map your non-common domain assets, often also called 150% or superset assets, to features of your feature model. For example, you might have a superset of requirements in DOORS Next. And let's say 20% of those requirements are not part of all variants, but only needed if a variant includes certain features or has been configured for a specific market. Those are the 20% of the requirements that you map to the features of your feature model with the help of an in-tool integration provided by Pure Variants for DOORS Next. Working on the feature models in Pure Variants and the domain assets in IBM ELM, so this is not just limited to DOORS Next. So we also talk here about Rhapsody, Test Manager, about your code in EWM. Working on those feature models in Pure Variants and the domain assets in IBM ELM is called domain engineering. This is where engineering assets are created and made ready for systematic reuse across multiple product variants. In application engineering, you then want to make use of those domain assets in the scope of a single variant. This is done by creating a variant model in Pure Variants for one specific product variant. In the variant model, you can see all the features. Okay, just checking you really can see it. You can see all the features of your feature model, and by making selections, you decide which of those features become part of this variant. Pure Variants is supporting you through this process with real-time feedback and letting you know if the variant you are configuring is in a valid state and is helping you to determine which other features must be part of the variant or can no longer become part of this variant based on your previous decisions. As you have initially mapped your features to your domain engineering assets, Pure Variants can now generate the variant assets for a specific variant based on your variant model. So it can generate out of the superset requirements architecture code the variant-specific instances. And this works across tool borders, across asset types, And as you make use of the same feature selection to generate all of these assets across tool borders, you can be sure that also you are crossing borders, you have consistency of your engineering assets. And after all, you save a lot of time as you configure variants and make decisions what to reuse on a higher level. So instead of scanning manually hundreds of thousands of requirements, a bunch of big architecture models, and manually let hundreds or thousands of people iteratively decide what can be reused in a new product variant, you maybe go over 200 features. Your experts have put their knowledge into that model about interdependency. You make on that high level the decision what goes into the variant, and you let pure variants based on that knowledge generate the variant specific output. This can reduce your time to market, or to give a concrete example, your time from customer request to answer how much a new variant would cost and how long it would take to deliver it, and if it would be possible, and what would be the delta from multiple months to 2 to 3 weeks. So here you really can save time and money. And there's something specific when we talk about pure variants integration with the IBM ELM platform. The IBM ELM platform comes with the concepts of streams and global configurations to manage your engineering data and to baseline engineering assets, again, across the different tools and asset types in the IBM ELM platform. Pure variants is 100% compatible to this approach. To track the evolution of your feature models and variant models, you can make them part of a global configuration. So feature models and variant models managed in a pure variants model server can show up as a pure variant stream in a global configuration in IBM ELM. On the other hand, pure variants can generate variant-specific streams and global configurations out of a global configuration and streams that are holding your domain assets, your reusable assets. This gives you full control over the evolution of your engineering assets across time and across product variants. By this nice interplay of the version control system on the IBM ELM side and of the variant management with feature models on pure variants side. With pure variants, the content of your variant-specific streams is no longer manually assembled, but automatically generated out of your domain assets. And this is what saves you a lot of time. By applying this approach step by step to all of your engineering assets, you can realize a consistent reuse strategy and also increase quality. So there are some publications of our customers you can find online where they tracked how the introduction of new errors while extending the product line has been drastically reduced by following such an approach, and also how they were able to more than double the lifetime of their product line as using such a dedicated approach also avoids erosion, so drifting apart of your different variants of your product line over time. So let's come to the quick glimpse at the product that I promised at the beginning. So we will have a look only at the specific part and specific task done with pure variants and IBM ELM platform in combination. I want to show you how easy it is to configure a product variant based on an existing feature model with the pure variants web client, and how we can then let's start here, and how we can then switch to the ELM side to see what are the implications for your requirements in DOORS Next of your feature selections for that variant. And we will then also instantiate a variant-specific stream. So let's get started here in the pure variants web client. So here we have an example project opened of variants of front car light systems. And I'm here creating a new variant for the US market. So I just start by giving the variant a name. I can in the next step decide whether I want to start to configure this variant from scratch, or whether I want to inherit some decisions, some feature selections from an already existing variant. And I can also decide in the next step So here we start from scratch, and I can decide in the next step whether I want to configure the variant in one go or in multiple steps. So here I go for the one go approach, as I want to show you a short demonstration and the outcome of this. Let's open the variant model. And so all this is happening in the browser, right? Let's start configuring the variant by selecting the features we want to have in this variant. And you see we have multiple functional features here in the feature model, but also we modeled the markets as feature. And as we want to make a variant for the US, we here select USA. And this will have an implication. You see all variants in the USA of front car light system require hazard warning. So if I select the market, hazard warning is auto-selected for me. So Pure Variants understands what rules you put in here and takes care that they are taken into account and your variant is valid. At this point, it is not yet valid, so you can follow the errors that are shown by Pure Variants, select them, and to find the places where you have to open decisions left. And each time you make a decision, the model is re-evaluated again. You get real-time feedback if it's now valid or not, if there are missing decisions. You can finish now configuring your variant by including additional features, by setting parametric values. Some of the values will be calculated again based on rules you put into the model. And all of this is used ultimately to control variation points in your different engineering assets. In Pure Variants, you can also get a good overview of variability across your different product variants. So here we can see which features are part of which of our existing variants. So each column you see here on the right-hand side is representing one variant, and we can see at one glance which features are part of which variant, which attributes are selected for which variant. And of course, this view is also filterable so that you can easily get answers to your questions, like other features that are commonly used across all variants, even though they have been modeled as optional. So I have a chance to reduce complexity on my product line. Are there unused features? All of this you can do. Let's come to the solution side. So let's say we have configured a variant this way. Now we want to preview it. We want to get an understanding of what this means for our actual engineering assets. So I now can navigate to Rhapsody, to Test Manager, to DOORS Next, and I can have a look at this variant. So here in DOORS Next, I have here a superset of requirements opened. And on the left-hand side, you can see we have the Pure Variants widget integrated in DOORS Next in the sidebar. It already shows the features of your feature models. And via drop-down menu, we can now select one variant we want to preview here in DOORS Next. And by clicking on the preview button, the widget calculates which requirements according to your feature selection will be needed in this variant and which ones will not be needed, and will gray out all the ones that are not required. So here nothing is generated. It's just a preview for your engineers working in the different engineering tools to understand, depending on the variant that I'm interested in, what would be part of this variant. Quick and easy. Now I can also, of course, if it's time for that, and I'm sure there are times where I want to do that, I can instantiate out of those supersets separate variant-specific instances, only holding those subsets of requirements, test cases, architecture, and so on that you need for a specific product variant. This is done in a step we call transformation. And I want to here show you the most common transformation for the IBM ELM platform, which is the stream transformation. So your superset engineering assets, in this case, your superset of requirements, is located on DOORS Next side in a stream. You have baselined it to express that this is now a valid superset out of which you want to generate different product variants. Now you can tell Pure Variants to do exactly that, and let's do that. From here, we can pick in DOORS Next the variant we want to transform, and via click on the pencil button here, we automatically can switch to the Pure Variants web UI, to the web client, and immediately exactly that model in the right version is opened. And I can now pick what kind of assets I want to transform. Here, I just want to transform DOORS Next assets. I trigger the transformation. In the background on the pure variance server, the transformation is running. I can continue working in the meantime. I can trigger multiple transformations in parallel if I want. And if I come back to DOORS Next, I can now switch to the newly generated stream and see what is the output of this transformation. And you see in the output, we have a separate stream for this variant based on my 150% stream. And in here, only the requirements and chapters are included that are needed for this specific variant based on its feature selection. And if I want, I can bundle such a transformation to not only transform a DOORS Next stream, but also to transform in one go the streams holding my test cases in ETM, the stream holding my architecture models in Rhapsody, so that they are all consistently transformed in one go in their own variant-specific global configuration, preserving the links that I created on 150% level. So it's a really nice interaction, again, of the version control concepts on ELM side and the variant management with feature models on pure variance side to really give you a good experience to confidently save time, generate what you can generate based on already known facts your engineers put into their models, and save time for innovation. So I want to come to an end here. Let me give you a brief summary of what we had a look at. So what are the key points to take from today's session? You can significantly increase the engineering efficiency of your company and gain a competitive advantage by maximizing the reuse of your engineering assets. We had a look at feature-based product line engineering as a standardized approach that major players from different engineering domains transitioned to in the last 20 years. With pure variants and with pure consult and our worldwide partner network, a successful knowledge transfer can be guaranteed to support your transition to product line engineering with training and consulting. We had a quick demonstration of the Pure Variance web client and the Pure Variance connector for DOORS Next as an example of all the connectors that come with Pure Variance out of the box, and discussed the deep integration of Pure Variance with the IBM ELM platform. If you want to get started, it might be good to know that Pure Variance fully supports containerized deployments, making on-premise and cloud deployments, as well as updates of those fast and easy. We also have a prepared training for your IT if that's needed. We believe most IT experts already are in the topic and can perfectly work with the templates and the documentation we provide here. Pure variance tasks like generating a variant can be fully automated as part of your build process. So we put a lot of focus on that topic, CI/CD readiness. So the same way you want to automate generating your engineering assets based on a variant selection, instead of going manually through all your engineering assets, you may also want to automate that step of pushing a transformation button, and that's totally possible. So no problem here. If you want to work with a transformation build farm, this is done by many of our customers. Also, last but not least, Pure variance does not get in your way. If you want to continue development in generated variance assets that you have formally transformed, you can do that and still receive automated updates from your reusable domain assets. This gives you full flexibility in your development process, and that's a unique selling point. So there's no, to our knowledge at least, no other PLL tooling that allows you to do that. Why do we allow it? Because we listen to our customer, based on their feedback, there is a need for such flexibility. Reasons are divide and conquer. If a new functionality shall be developed, a lot of times it's decided to make it happen first in the context of a single variant, and in the second step, enlarge the solution to also make it available for the product line. Sometimes it's just that there's only funding specific for a variant that is developed in the context of a project. So therefore, that funding is limited, it needs to be done there. And later on, it's decided whether it's worth to invest additional time and money to make it more generic. So those are some of the reasons why we have this in. last, if you want to know more about product line engineering with pure variants and how to make the transition to systematic reuse, get in touch with us. Our partners and us, we will happily support you from the first meeting to answer your initial questions over a guided evaluation and POC, up to the company-wide application of product line engineering. We can support you with best practices and provide you with advice during the stepwise introduction of PLE and help you to make it a success, and also to not only at the end profit from it, but also to get the early fruits harvested and profit right from the beginning. Here I want to stop the presentation, so you can reach us, maybe that as a final comment, via the contact form on our website, pure-systems.com, via contact@puresystems.com if you prefer email, or via LinkedIn. If you look for pure-systems, you will also find us there. Or check out the Pure Systems partner page, which you can also see here on the slide on the IBM website. And if you want to study additional material at your own pace in advance, have a look at the tutorials on our website. Or if it's more about methodology and a bigger picture, also have a look at our YouTube channel, where we have collected many videos like how to apply pure variants for different engineering assets, motivating the bigger picture, going into detail on CI/CD integration and so on. So yeah, you're welcome to have a look there. With that, what's left besides saying thank you very much for your attention. I hope you could draw value out of that presentation. And finally, my question to you, are there any questions? Do you have any questions?
Yeah, Robert, if you can look at the bottom of your viewing area, there are a number of questions that have come in. Would you like to read them and answer them, or would you like me to read them to you?
Oh, I can see. Thanks. That's very nice. I will just go over them. I see it's quite brief questions. So one is, can you add more features to a variant after it has been created? Yes, good point. Typical use case, and the answer is a clear yes, you can. So of course, your product line assets evolve over time. You want to grow the set of available features of your product line over time typically, and you want to be able to include new features into existing variants. That's fully supported. Details we have to discuss separately. It takes too long. Let's go to a next point. At this point, what role in the project typically runs this generator, admin or end user? So good question. Typically, those are users, but not just any user. So you have dedicated roles, of course, here. We strongly recommend to have dedicated responsibility for building and maintaining the feature models. This has to be a role. This can be taken over by an existing role. This does not have to be a new role or a new person for that role. That has an overview and understanding of the overall system. So a lot of time this ends up in systems engineering. But must not be the case. It depends a little bit on your roles and how you cut them. The configuration of the variants, this is a lot of times done by the projects that want to profit from what is there, and then also the transformation of that. Sometimes the transformation is automated, so no one manually triggers that, just the project teams configure the variants, and then overnight they are automatically transformed. This now sounds like it always takes a lot of time to transform. That's not the case, but of course, this depends on the size and the amount of data you have connected here. If we talk about generating a variant of a whole car or an airplane, this might take some time. Then we have here another question. Do you perform one transformation on a global configuration stream? So how is this technically done? You can bundle transformations, and you can tell pure variants to explicitly generate during the transformation also a variant-specific global configuration holding all the assets inside. So yes, you can do that. There's a specific so-called global configuration transformation that you then bundle with the DOORS Next transformation, ETM transformation, Rhapsody transformation, for example. And then pure variance takes in account that there are global configurations, that your 150% assets are coming from global configuration, that they are linked to each other. We can also deal with nested global configurations here. So we will replicate the structure you created on the 150% level of global configurations and streams. For the variant, you will be able to see then, if you look at your history, out of which baseline of your superset the variant specific global configuration has been generated, and what has been removed or injected during the transformation to make this variant come into existence. Here's the question into the same direction. Does pure variance create the global and local streams automatically? Yes, both, yes. We do that during transformation. Then that's also a good question. I didn't show this today, but you can find a lot of demo material on our YouTube channel showing this, or just reach out to us. We happily also show it to you. How is the link between the features in pure variance and the artifacts in DOORS Next? Each feature, can it be linked with more than one requirement? And yes, of course. And that's a good question. So how is it linked? This is done with feature-based rules that are stored directly on the requirements, because these rules define basically the mapping between feature and requirement. And why do we use rules for that and not just single links? Because you sometimes have more complex rules. A rule can be, if USA and fog light has been selected, then this chapter is relevant for my requirements. If that's not the case, this chapter is not needed, but maybe a different chapter, or a different requirement. So you can have end-to-end relations here. So one feature is typically connected to multiple places in your solution assets, also in a requirements document. And also it is quite common that 2 features or 3 features in combination are controlling, if they are all active, whether a requirement is part of a variant or not. And this can be expressed with help of those rules. And this is, again, these rules, it's not free. So in the end, they are saved as text, but you have an editor in our widget, and also for all the other integrations for Rhapsody and so on, we have editors included that you can write with tool support those rules. The editor is showing you, as autocomplete functionality is showing you all the available features, is ensuring the syntax is correct, so that you are not pointing at some features that are not existing. And then the question, I think I mentioned that earlier, does a transformation at global config level trigger changes in a Rhapsody-based architecture model, in addition to requirements and test cases? Yes, so we have also an integration for Rhapsody. You can connect your features also to a superset Rhapsody architecture, and then we also generate out of a superset architecture a variant-specific one. Can we see how the feature model definition is established in a little more detail? What data needs to pre-exist in DOORS Next? So that's a good question. That's a little bit going into the direction at which point in time do you introduce variant management, and in which order? What is there first, the domain assets, the feature model? So just let me tell you how it is in reality. We have customers that know from different employers that they are that PLE can easily become a topic if you have product variants, and what a hassle it can be if you not have it, and what pains it can cause. We are in touch with and working with multiple startups who have identified this as an issue early on, and from day one start using or introducing feature models in parallel to building up their domain assets to really work with that approach, starting with a greenfield. But the much more common case is that we help our customers who are in there for years and decades in the business, have a lot of engineering assets that from up to this point, they manage project by project or product variant by product variant, sometimes with some reuse, ad hoc reuse, working with these Excel tables, and so on. And then we help them to make the transition step by step. So then basically what is done is that we help them to analyze, if that's wanted, their existing assets to get the domain assets out of those, to basically you have to aggregate them and identify the differences. Depending on the asset type, this is easier or more complicated. There are ways to help. and the feature models are often built up in parallel, actually. Yeah, so I can give you an additional hint. It's easier if you start trying to connect high-level engineering assets like your system requirements or your software or system architecture. This is already quite high level in granularity, and it's much easier to identify features if you look at such assets than if you look at code and want to get a feature model or identify what are features that should go into your feature model based on code. Yeah? Not every variation point in code results in a feature. There we can help you with cluster analysis, so identify places in your code that are maybe always together enabled or disabled, because if you identify such places in the code, you can ask the engineers the question. So we saw that these 10 places are always activated or deactivated at the same time. What's the reason for that? Yeah? Or reused at the same time. What's the reason for it? And then you get in discussion like, yeah, this is because it's for a specific region, and all of a sudden you know what you need a feature for. So there are ways to start on every level, but it's easier to start on the higher level. Yeah, does the preview and eventual transformation consider and include dependencies in requirements, test cases, and models? You can do that. Yeah? So, I mean, it's smart to put as much of your knowledge about interdependencies, if they exist in general on high level, between your features in the feature model, because then they will be enforced across all your engineering assets. But if you know that certain requirements have certain relations to each other, we are also allowed to add that information directly to the requirement side in a way that pure variants can interpret it. And then we do that and let you know if there are issues, and you try to combine things that cannot be combined. If I create multiple variants, is that multiple global configurations in ELM? It can. Yeah. So this depends. I just showed you today the stream transformation. Yeah. If you run a global configuration transformation each time for each variant, this would mean yes, you would end up with a global configuration for each variant. The question is if you want that and need that. Yeah. Alternatively, we can also just generate variant-specific modules into a project that then has subfolders for different variants. This depends a little bit on what you want. Yeah, so this can be the case, yes, but not necessarily. Yeah, here we support multiple types of output. Is there more guidance available on co-evolution where core and variants are being developed in parallel? Yes, there is. This would typically be a topic. Yeah, we would like to help you in your context if that's possible. Of course, if you're working on defense projects, we understand this might not be the case, but if possible, we like to do this in a workshop together with you. If it's not possible to have a look at your assets together and discuss them, we also can give you an example, so a fictional example based on which we can discuss your questions. So this can, again, here I want to point at our partners who are also excellent at providing support here, at consulting here, to help you to really understand how can this be used in my context. How does this fit into my workflow? What level of reuse is required to get tangible benefits from pure variants? Yeah, here I don't understand the direction of the question. I would rather say pure variants enables you to do reuse. If you want to know, maybe let me interpret the question. Yeah, maybe I got it wrong, then sorry. You can reformulate maybe. If you know that all of your variants, in each of your variants, if you compare two of them, they are 99% different, and so there's only, or 90% different, and there's only a very small amount of things they have in common. You really have to ask yourself the question, is this really a product line? Or do I just have one or two reusable components? Then you maybe don't profit so much from that approach. But where you definitely profit is if you either are in the situation that you have many different variants, so tens, hundreds of variants that have some variation points between them, but have, let's say, 60 to 80, 90% commonality. Then, of course, you want to make as much reuse, not only of the common assets, but also on the shared ones that are part of maybe half of these variants or 2/3 of these variants, then you drastically can profit from that approach, not only in the generation, but especially in the maintenance over time. And also to always keep a clear understanding what is part of which version of which variant. I mean, you have these 2 dimensions. Each variant also can evolve over time if we talk about over-the-air updates and stuff like this, not only in this case, but especially then. And then this can be a tremendous help. And the other thing is you can also profit if you even if you only have 2 variants, but you have many fine-grained variation points inside of them. So this can again mean that 60-70% commonality are there, but then you have variation points that do not mean I activate or deactivate a doors module, but that mean I have many points inside there, because of regulations of different markets, because a certain function or a certain feature is cross-functional, so that it really is not just in one place, it's distributed across my assets. And there you can really strongly profit from that approach. Having a look at time, I think you can pick another question. Yeah, is it possible to have partial deliveries performed? Yes, absolutely. So I didn't show it in detail today, but when I created the variant, you could see that you can decide to run a full or partial configuration. The meaning of this is that in a full configuration, if you leave certain decisions open, this can lead to pure variants showing you errors, as the decision must be made to finally end up in a valid configuration. If you pick partial configuration instead, then I see there are issues with the screen sharing. Sorry. 1 second. But the screen is not so important at this time anymore. So then pure variants understands that not making a selection, leaving that decision open, means that you might want to leave it open on purpose and is not throwing an error at you in that case. And it also means you can stepwise transform your solution assets. So you can generate out of a 150% superset of requirements, a 120% sub-superset for a specific region that in the next step you take together with a reduced feature model to generate out of that the actual variance of the region or of the customer or whatever it is you want to create a sub-product line for in an automated way. So this is fully supported also across tools. Then there's a question related to the versions of Pure Variants and the web client. So with Pure Variants 5, our former major release, we introduced a web client, or first parts of the web client. So it was possible to view feature models and to configure variants in the browser. With Pure Variant 6, our recent major release, we heavily extended our web client. So in the web client, you can now also edit your feature model. You can add new features. You can add new restrictions, relations between features. You can configure your variants still, of course. You can trigger transformations. You can trigger server-side transformations. So a lot of new stuff has been coming there, and we keep working on the web client to make it more and more powerful. With, for example, IBM ELM customers in mind, that are used to work with their browser-based tool or to access the ELM platform via browser and want to stay in the same environment, maybe just have a separate tab and easy navigation between the ELM world and the pure variant side. Just then checking time. So then, again, co-evolution questions. Is it possible to update a Rhapsody model, so regenerate it again, to receive changes? Yes, this is possible. We have a whole session recorded about that. You might want to check our YouTube channel or reach out to us so we can also demonstrate that. We will happily do that and answer in more details the questions you have about co-evolution at this place. I can tell you that, of course, this also means conflict checking. There might be conflicts. You might have changed something on product line level and on variant level in parallel. these conflicts will be made visible, and then in this case you have to make decisions. So that conflict resolving is in that case not automated, but everything else, yes. What is the relationship between features and transformations? So this is, I have to refer back to that one slide where we had feature models, variant models, domain assets, and variant assets. Feature models, here you define in a feature model which features exist in your product line and can become part of your variants and how they are interrelated. This is what you put in the feature model. The scope here is the whole product line, right? In the variant model is based on the feature model, but the scope is a single variant. So in the variant model, you see all the features you have configured or you have defined in your feature model for that product line, but now you're in the scope of a single variant, and here you select this subset of feature that goes into that specific variant that is relevant for that variant. And the features, they are related, and you do this initially actively. You relate them, you are mapping them from the feature model to your superset engineering assets, to the variable parts of them, to be precise. And because this mapping exists, then based on the feature selections of a variant, pure variants can calculate with that information which parts of your superset assets should be in your variant specific assets and generate them. And that generation process of actually instantiating the variant specific assets out of your domain assets, that's called a transformation. So in the transformation, basically, the variant models are evaluated, and the rules that you put on your solution assets that connect your requirements to your features, your architecture elements to your features, to automatically generate based on that information the variant specific output. I hope this helps. If it's not clear enough, again, please reach out to us. We happily explain it in more detail. Can you view and edit feature models in Rhapsody? You can view them, yes. The intention is not to edit them there, but to use them there, yeah, to connect them also to your Rhapsody architecture models. Yeah. So editing, no, but you can view them, and we have again editor functionalities included, autocomplete, everything, preview, so that like we saw for DOORS Next, you can have this mapping instantiated initially, and you can then preview different variants. How would the architecture for the US variant look like? How would it look like for the EMEA variant or whatever? Yeah. Can you use a specific method to build a feature model? Yeah, yes, and basically this means you will have to get your experts together. Yeah, you are the experts in the engineering of your engineering domain. Yeah, and we can add on top, or our partners, yeah, can add on top the expertise about feature models, how to get to a good feature model. We also offer these trainings I briefly mentioned earlier, and our partners also do that. So if you want, you can request a 2-day training, yeah, for example, where you get on day 1 a full coverage of the PLE approach, and how to model good feature models, yeah, get different guidelines, yeah, get hints on what are good or bad patterns for feature modeling. On the second day, learn how the connection to your solution assets is made, all with hands-on training sessions, everything prepared so that you also not only understand the concept but feel confident in applying the lessons learned in the tool. And then we happily also follow up with you if you want to understand how to apply this knowledge to a concrete project, to your concrete case. Yeah, I just showed to showcase today a very basic part of feature modeling. Yeah, how exactly you model a feature model also depends on the complexity of your product. So if it's more complex, if you have more complex situations like a system with multiple components, each component as a product line, we also have concepts for that. If it's rather simple, then you will be fine with building up 1 or 2 feature models that live next to each other. So we can help you there and point you at the right mechanisms that are included in the language and in the tool to use to best tackle your challenges and really model the complexity in variability that you have. I mean, it's not that you are introducing it by modeling, it's just that you make it visible and controllable and to realize automation potential. Yeah? If you just don't do it, you will have to deal with it sooner or later. Yeah? Here I want to stop. There are more questions, but we are running out of time. Thank you very much for all the interesting and good questions. Yeah. And as I said, I can just offer to you or reach out to us, reach out to our partners, ask IBM, your IBM contacts to establish contact. Yeah, and we can happily organize a meeting to discuss your questions, to give you additional demonstrations, go into more detail on whatever you're most interested in the topic.